And that brings us around to tonight's presentation. Just in general terms, astronomy. It was August last year there when Clint gave us a talk on the radio astronomy. And Perry's here this evening with the, what would you call it, Perry optical version? No good enough. Perry's been described there as one of Australia's leading astronomers. He's an astronomy educator, author, broadcaster, and possesses a wealth of expertise on all things skybound. He's been an astronomy educator for more than 20 years, writes a regular astronomy column in the Thursday editions of the Age newspaper, and he's often heard on Melbourne radio and on TV. He's past president of the Astronomical Society of Victoria, and he's currently their media liaison officer. Perry's also president of the new Mount Burnett Observatory, an astronomical facility in the Dandenong Ranges previously run by Monash University, and a few of you would remember our involvement up there with Comet Shoemaker-Levy when Tuck Joy was and Tuck, and who was the other one? Max, you're in charge of that too, weren't you? You and Tuck there. That was the club's involvement there. So Perry's there this evening there, Optical Astronomy. Thanks very much for giving up your evening and coming along to our club, Perry. Welcome.
Thank you. Do you want me to use this or?
Probably best to. Just take it out,
yep.
Perry, and you can walk around with it.
Okay.
Enough lead there.
One, two. Good evening, Seattle. Oh, sorry. Well, takes me back to my days as a rock musician in a band. It's good to be here tonight with you, ladies and gentlemen. I'd like to thank Carl and Roger, of course, the original contact, for inviting me to give you a talk this evening. And with the things that I'm involved in with the Astronomical Society of Victoria and also Mount Burnett Observatory, there appears to be a good solid connection between your club here, EMDRC, and both of them, because Jack was telling me earlier, and I just heard again from Carl, about the observation of Comet Shoemaker-Levy 9 when it collided with Jupiter back in 1994, I think it was July. And some of the observations that you guys made up there, I think Jack has volunteered to forward some of the images, and that would be very welcomed up at Mount Burnett. And at the same time, if any of you have an interest at all in any sort of astronomy, please feel free to get onto the websites, have a look at both the ASV and the MBO, and please come up with the MBO up at Mount Burnett Observatory. It's open every Friday night for what we call Members' Night, and there's usually a talk, there's supper, and afterwards we'll look through the telescopes if the skies are clear. With the ASV is the largest astronomical association in the Southern Hemisphere, and I think you almost are the radio equivalent of it, with somewhere between, I think it's somewhere between 800 and 1,000 members in the ASV. And because it is so large, there are so many activities. It's possible to do something astronomical with the ASV every night of the week for a month if you were so keen to do so. Carl mentioned some of the things that I'm involved with, but whenever I meet people at parties or anything like that, they usually think I'm an astrologer. And of course there's nothing further from the truth between an astronomer and an astrologer. Astronomy deals with everything in the universe and how it works and how it got here, and is very much observationally based, where you can absolutely make predictions, like next Friday morning there's going to be an eclipse of the sun. It's only going to be partial here in Melbourne, but we know that it's going to start at about 7:02, and by hook or crook it will start, and mid-eclipse is going to be about 8:02. And again, that's actually going to happen, whereas if there's an astrological prediction, don't put your money on anything. And to tell the truth though, as a younger man, I used to go out with an astrologer, and she was a lovely woman, and we would take wonderful romantic walks on balmy nights. And one night she looked up and said, "Oh, look, the moon is in Pisces. That means it's a wonderful night for making love." And I looked up, and with my astronomical bent, and I saw that the moon was nowhere near Pisces, but damn, I knew when to keep my mouth shut. So the two are nothing alike. But for my talk tonight on optical astronomy, because I know Clint has given you the lowdown on radio astronomy, and also Jim Pollock has talked about meteor observations using radio. Is that correct? I think. Yep. So this is something that you can do with your other main sense, which is your eyes. And I thought, as many people that are involved with radio have quite a good technical bent to them, that perhaps I ought to talk not so much about the gee whiz, that's so many light years to this, and if you could shrink the Earth down to the size of a 4-inch sphere, it would become a black hole, and all this stuff. And I thought I'd just totally avoid that and talk about something that you could do yourself in astronomy, even without a telescope. And that is to use a digital SLR camera to make some photographs of objects in the sky. And I'll go through some of these and explain what they are and how the images are made. But essentially, all you will require is a tripod, a little bit like, hi Mum, what's happening over there with that camera, holding it up, and the digital SLR goes on top of that, and you can do an exposure for about 25 seconds and you will get an image of the stars in the sky. There is one caveat, however, and I will explain that as we move through the talk a little bit further on. So I thought I would begin with this reasonably well-known image from a very well-known post-impressionist painter, Van Gogh. And I don't know if any of you are familiar with this painting or if you've ever stood in front of it, but when you do stand in front of it, it transcends the years when it was originally painted and now, and it also has an aesthetic to it which almost knocks you over, because in real life it is just so vivid, just so stark, and quite frankly can be intoxicating. And an artist is taught, or they teach themselves, to represent nature, or whatever it is that their motif is for a particular painting, in the truest possible sense. And when you look at this painting here, a couple of lovers out on an early evening walk, the River Rhone, and behind it we can see the lights of the town, and above it the stars in the sky. Some of you may actually recognise this group of stars here. Does anybody? Yeah, Ursa Major, the Great Bear, or sometimes referred to as the Big Dipper if you come from the British Isles, or the Plough, and those stars are rendered onto that canvas with a large amount of fidelity. In fact, so much so that we can tell when that was painted, to the hour, which is no mean feat, and it is a striking representation of the sky. But I would put it to you that this is just as striking. An image taken by Phil Hart, who is the section director of the astrophotography section in the Astronomical Society of Victoria, and it is of the Aurora Borealis, the northern lights. We do have the southern lights as well, which is Aurora Australis. Strangely enough, fewer people, even in the southern hemisphere, where we are, know about the southern lights than those that know about the northern lights. And the explanation is easy, because there are great land masses that continue north towards the pole, where this activity predominantly takes place. And it's the interaction with the solar wind and the Earth's magnetic field. So if you're in Antarctica, you get to see this sort of thing all the time. If you're in Sweden or Norway or Iceland, Iceland is where Phil was, you get to see it much more often than what you would in Central Europe or the Mediterranean. And it's the same with us here, but you can see it, surprisingly, you can see the southern aurora from even the latitude of Victoria and sometimes New South Wales, depending on how strong the activity is. Now, if some of you have got an Android phone in your pocket, a smartphone, and by the way, let me tell you a story. I've got a smartphone in my pocket, but it didn't take long to figure out that when you combine smartphone with a dumb person like me, you still get a dumb phone. But if you've mastered your smartphone, then you can get a little app called Aurora Buddy, and it will start giving you messages when aurora is starting to occur. Now, what you need to do then is try and get away from the lights of the city, and you can see it visually. It's probably easier to photograph, however, because with the photograph you can open the lens or the shutter of the camera for a period of time and let the photons collect, and you get a deeper image. Here in this image you can see the Seven Sisters, the Pleiades, and over here is the V of Taurus, and the shimmer of these magnificent natural light displays. I think we may have missed an image. We'll go back. One of the caveats that I made mention earlier is of the lights of the city. The lights that externally light up many advertising billboards, street lamps, external house lighting, can have a very detrimental effect in what we see in the sky. It acts a little bit like this. It's like well, what actually happens is that because these lighting fixtures don't have horizontal cut-offs, it allows the illumination to go sideways and upwards as well, and it illuminates dust particles in the atmosphere, and we cannot see through them to the fainter objects in the sky. This image, some of you may recognise it, is of the Southern Cross and the two pointers which always point to the top star of the cross. This is how we see it from within the suburbs of Melbourne. And this is what you see when you get out into the country, away from city lights. So let's just go back one. Now I ask you, which sky would you rather have, that one or that one? And so, in order to see the fainter objects, the more interesting things in the sky, such as Aurora, then you have to try and get away from the lights of the city. Furthermore, because this is not visible in any other part of the sky except the southern part, it's great if you can get down the peninsula to Balnarring or Gunnamatta Beach or something like that, where you're just looking straight down into the sea and there's no lighting between you and the sky except the odd scallop boat or something like that. And then you get to see the magnificent splendour of the southern sky. And you can do constellation portraits with your camera around the south celestial pole or in the southern sky. You can keep your shutter open for about 30 seconds. Anything from the centre of the sky and towards the north, probably about 20 seconds. Otherwise you start getting trailing because the Earth is moving. So as we move eastwards, all the stars appear to move towards the west. Now, this is an image that's taken up at the Society's dark sky site, which is about an hour and a half or so north of Melbourne, right in the middle of nowhere, and it's very dark up there. In fact, it's so dark that when the Milky Way is overhead, it can cast a shadow. So this is where we do our serious deep sky observing. And here, this is one of the things that I do. You can see there's a whole bunch of people around this green laser, and that's me using the green laser to show everybody where all the objects of interest are in the night sky, pointing out the constellation and the brightest stars. And here there are so many stars to be seen that in fact I bet very few of you can find the Southern Cross and the pointers. Can anybody do it? Where are they?
You need a pointer to point to the right hand.
Yes, right here. And the pointers are down below them, again pointing to the top. And here's the Milky Way, and this dark area is called the coal sack. It's called the coal sack because it is that dark, and it's a little bit, well, it's a lot. It's a huge cloud of dust between us and the background Milky Way stars, and it's hiding them from our view. The Aboriginals make a constellation out of this and the other dark lanes in the Milky Way. We'll see those a little bit later. Over here, that is not a stray piece of the Milky Way. That's the Small Magellanic Cloud. And the Small Magellanic Cloud is named after Magellan because it was his voyage that reported news of this little thing after it circumnavigated the Earth and went back to Europe. And we now know that that little thing is a satellite galaxy of our Rhone galaxy, the Milky Way. And it orbits around us over many millions of years, a little bit like the moon goes around the Earth. And it contains millions and millions of stars in there. There's nothing like that in the northern sky. But again, you can see the difference between a sky that you would see in the city and one that you would see from somewhere much further away. This image and the previous were taken by another one of our master astrophotographers, and this was taken by Alex Cherney, and there's a big radio dish for you. Bet you'd like to have that in your backyard. But this is the Parkes radio telescope, which of course is featured in the movie The Dish. Who's seen that particular movie? Great movie, isn't it? Fantastic movie. And again, it captures a magnificent vista, and I again would like to throw up the idea of some astrophotography being every bit as worthy of an artistic judgment as anything that any painter has ever done. And this is a magnificent vista. Here we have the saucepan, there's the handle, 3 belt stars of Orion. All of this make up the constellation Orion. Over here are the 7 sisters again, the Pleiades, Taurus. This is the moon, last quarter moon, Jupiter and Venus. And a little bit of wispy cloud in the way. What kind of lens would have been used on the camera for that? Just a 50mm ordinary lens, nothing special at all. So just straight out of the box as you would get your camera. Yes?
Do the planets in the sky appear different with the human eye?
Than what?
Than on the camera.
No, not really. They appear much the same, except here they may look a little bit brighter because the exposure is a little bit longer than what the human eye would see in one go. Yes, sir?
What ISO rating would these shots be taken?
You can rate it up to as high as you like, but the quality starts to degrade after a while. But you can go up to 1600 or something like that, even more if you like. And then you can use one of the many programs that are available now, such as Photoshop or Registax or whatever, to work on it and massage it up to something a little bit more. But the image that you would get from the original shot wouldn't be too different to this. This features the Milky Way, and you can see all the dark nebulae, the dark dust clouds, which will eventually form new stars in the Milky Way between us and those background stars. Now, I mentioned that the Aborigines have a constellation here, and it's not the Southern Cross, which is up there, not the Pointers, which are part of Centaurus, the Centaur, but they make up a constellation made up, unlike the Western constellations, made up of absolutely no stars whatsoever. In fact, this particular constellation is made up of all the dark gas and dust in the Milky Way. There's the head and beak of the emu, there's its neck, and there's its body. Can you see it? And it is very, very large in the sky. It takes up a huge part of the sky, and this time of year is the perfect time to be out there looking at this. Later on in the year it changes orientation and isn't so easy to pick out. Also, you can see lots of little clusters of stars here, situated throughout the Milky Way. And the Milky Way, of course, is, I'll use one of these folders. The Milky Way is our galaxy, instead of being viewed face on, being viewed edge on, so that you're seeing all the stars lined up together. And that's not a bad representation of the thickness of the Milky Way. It's about 100,000 light years in diameter from side to side, but the thickness of it is only about 6,000 light years. So it's a disk. And that's why all the stars combine together to give us that view of the plane of the Milky Way. Now, I said that all of the images that I was going to show tonight, or just about all of them, have been taken without a telescope, except for a couple, and this is one of them. This kind of shows you the difference in the way that cameras react to certain frequencies of light, as in the spectrum, as opposed to our eye. This is the Orion Nebula, and the Orion Nebula, you can see it there in a photo taken with a telescope. There's another photograph taken with a telescope, but treated so that it resembles the way our eye would see it through the telescope. And the position of this is right there. Right there between those three stars, or what appear to be three stars, it's the middle one. And you can see it just with your naked eye. Binoculars give you a better view, and you can see it as a luminous little patch, and then a telescope would give you this sort of view. if you mated a camera to the telescope and you tracked for a little while, you would get this sort of thing. And most of the CCD chips in cameras are more sensitive to hydrogen alpha than what our eyes are. So we see it basically as a greyish green area, all this hydrogen, whereas in a camera it looks more pinkish, reddish, burnt brown. Another thing that can be observed and photographed are things such as this, which are comets. This is Comet Mcnaught, which was around in January 2007. Did anybody catch a glimpse of that? Put your hands up, right up, let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. At the back, tell me your impressions and where did you see it from?
We actually saw it at the Hamburger Observatory, not in the observatory, but on the ground, and actually took some photos of it.
Okay. Unfortunately, you were in a city and you wouldn't have seen it as well as what you would outside of, but I bet you got something pretty worthwhile anyway.
We got a few good photos, and we were travelling back to Melbourne, and a couple of times on the view, and we sort of ventured off a couple of Ks and made other attempts where we could.
That would have been the perfect sort of location. And for anyone that didn't see it, I feel very sorry for you, because it was not to be missed. Now, I did my very best, got on to the radio and told people about it, and on the news, Channel 9 and Channel 10. And on the Friday night after the bushfires, the first time I saw it on that week from Victoria was on the Monday night, because there were lots of clouds all the previous week when it first became visible, and then the Monday it did clear and people were starting to report all sorts of UFOs and things from around Victoria, and I got lots of calls from newspapers and radio stations and police stations wanting to know what this thing was. And that was at the same time as when China had sent up its first or second spacecraft into space, or a rocket test that they were making, and lots of people thought it could have been it re-entering the atmosphere. It wasn't, of course. And on that Friday night, and we had some very clear weather for the rest of that week, I went down to Brighton Beach, and I used to like going to Brighton Beach during the summer and enjoying the sun and the sand and the surf, which there is none of, but the water anyway. And I might say that was the first time that I'd ever seen as many people on the beach at night as what I see during a hot summer's day at Brighton. It was chock-a-block, and everyone had a fantastic view. So for those that didn't see it, I'm sorry that you missed out. There is another opportunity, not for this comet to come back. It will come back, but I think it'll be, might be a little bit difficult for some of us to observe it. It'll be back in about 240,000 years. But there is another one which is making its way towards us and will be here in November, early November, late November. And if you hear about it, or if you follow me on Twitter, my Twitter account is #Perry Astronomy, then I'll give you news of when it's coming on. And I promise you, in my Twitter messages, I don't say things like, I'm now just going down to the hairdressers to get my hair done, and I've just bought a fantastic new skirt. But you will get news of things like eclipses. As I said, one's coming up this Friday, and you get news of various other things that are going on in the sky.
You want to wake that up on the whiteboard, Perry?
Yep, for sure. There we go. And I really promise not to send you a tweet saying, I've just had lunch with Tom Cruise.
Has that happened before?
Sorry. I won't be telling. So these are magnificent things to photograph, and you can get great images from them. Again, that caveat being to get away from city lights. And if you can frame your photograph a little bit, in other words, just have a look at what the foreground is, so that you can have something interesting in the foreground, it becomes much more an artistic statement then, and an aesthetic attraction for the eye, such as this. This is probably my favourite photograph of Comet Mcnaught, and that was taken on a beach in Adelaide by Michael Mattiazzo, who's a bit of a comet guru in the Astronomical Society. And you can see there's all the lighting around here, and it's casting shadows. And this thing was so bright that you could still see it. And that sort of comet perhaps occurs once in a generation. Two in a generation, boy, we're getting really, really fortunate. So it'll be interesting to see what happens with this new comet Ison as it nears the inner solar system later in the year. Now, comets are a little bit unpredictable. They're a bit like cats. They have tails as well, and they just do what they want to do. Herding cats is the expression, and I'm sure you know what I'm talking about. But at this stage, it appears like this will be one worth seeing, so keep your ears close to the ground, and you'll get news of it as we near that time. This is another great image of taken on Australia Day in 2007, and you can see all the people here on, oops, back, come back, Shane. This is Cottesloe Beach in Perth, and everyone's enjoying the celebrations, and there's fireworks here, there's a thunderstorm over there, and there's Comet Mcnaught. And the photographer that took the image had no idea that he'd captured the comet when he took it. It was only pointed out later. Now, when this comet was first beginning to shine, I should tell the story. You've seen these magnificent photographs. Here's my photograph of Comet Mcnaught. Yeah, and it's pretty pissy compared to the others, right? I'll take that on board. But you're not privy to all the information that will set this up. I was in Perth in January 2007 when this comet first began to shine to the naked eye. And this holiday, a friend of mine and I had booked our trip over a couple of months beforehand, and wouldn't you know it, on the trip back I managed to book in advance a flight on a Virgin plane that was leaving Perth at sunset to come back to Melbourne. And lo and behold, that was the perfect time to be looking for Comet Mcnaught. And this image was taken on a handheld camera phone, and not a smartphone, one of the old ones, from the plane through the window. And I thought, hell, I've got to share this with everybody else. So I called over one of the stewardesses and said, look, I'm an astronomer, blah, blah, blah. Can you tell the captain this can be seen out on the southern side of the plane? And you can see here there's one of the part of the wing, you can just make it out. And he made an announcement, and everybody moved over to that side of the plane. And strangely enough, yes, there was a friend of mine in Portland who was out looking at the comet, and he said, it could be apocryphal, but I'll take it as the truth. He said, I did notice a Virgin plane heading for Melbourne, listing really badly to one side as it went through. So there you go, you can just fortuitously book something or whatever. And
that's how I saw it, through a window on a plane from Melbourne back to Tassie, back to Hobart.
Oh, wow.
Window.
There you go, yep. So did you know about it beforehand?
Yeah,
or?
it was there, but that was the best view I got of it through the window, because it's dark over the sea.
Of course, yep. And the sun, as yet, had not perfectly set, I might add, when this image was taken. So the sun was still up, but the clouds were stopping it from being visible to us. What else can you do with your camera? Well, what do you reckon this image is? Any guesses? Sorry?
Movement of Mars?
Movement of Mars, yes.
It's sort of analematic, so I'm not sure exactly how you say the word. Analematic, to do with the equation of time and all that sort of position.
Yes, yep, you're on the ball. This is the first photograph taken of the sun every day, every week for a whole year at the same time on the same day. If it was cloudy, you'd go forward another day or another couple of days, and you just have to be very sure to make sure that you return to the same spot with your tripod or your camera, leave it set up in a position that, and height and everything else that you know of, and then you combine all of these images later. This is what's called an analemma, a Greek word, analemma. And this depicts the sun in the north at, this is taken at midday by the way, 12 noon each day, due north. And here is June the 21st, and up here is December the 22nd. And that's the journey that the sun makes in the sky every year. And it's a stunning photograph taken. Now you might think, oh look, I'm not sure that I can do something as technical as that. This was taken by primary school girls with their science teacher. Melbourne Girls Grammar. Yes, sir?
The effectively figure 8 that it produces, do the lobes change position or size depending on your latitude?
No. No. It will be higher up or further down depending on your latitude, but the distances and everything else between them will be much the same. Yep. And sometimes you may see that figure depicted on a world globe. Right? If you've got a globe, sometimes they used to put it on near the equator or the international date line or something like that. So this is something else that you can photograph just with a digital camera. And if kids as young as primary school can do it, there's no reason why adults can't do it. What else can you photograph? This is a meteor shower. Again, taken by Phil Hart, and it's of the Geminid meteor shower. And once more, we have some familiar constellations here. This is the Saucepan, or Orion, with Betelgeuse here, the red supergiant, Rigel there, the blue supergiant, Sirius. This is the brightest star in the sky. Over here is the V of Taurus. And here, these two stars, there, are Castor and Pollux. And the meteor shower, the meteors appear to emanate from that position. If you trace back all of their paths, they line up about there. So it's a perspective thing, a little bit like when you're driving along in your car and the rain appears to be coming from one spot in the sky. So the Geminids are active in early December, and if you have a moonless night, you can get images such as these. Once again, you need to be careful about the moon, because the moon has the same effect on the starry skies. It makes us see only the brightest objects and none of the fainter ones. It's natural light pollution, just like you get light pollution in the city. So it's best if you can do it on a moonless night. And this, what must have been a humdinger, would have been quite an impressive object. None. I'll just get back to you in a second, Jack. None of these meteors have hit the ground. They all burn up in the upper atmosphere, about 80 kilometres above our heads, because even though they appear as bright as all this, they are the size of a grain of sand. But because so much energy is liberated in a short period of time, and Einstein's equation, E equals mc squared, they burn up as brightly as that to create these magnificent light shows. And I was berated by a caller on 3AW one morning because they saw this fantastically bright meteor in the sky, and I said, well, it's probably about this particular site. And he goes, you know nothing, you've got rocks in your head. This thing was fantastic and huge. And but I said, sir, I may not have seen that particular one, but I sure have seen many, many more than you have at other times that would have been about as bright. But they're not. These things are tiny. Occasionally, they grow to humongous size and resemble something about as big as an apple pip. Jack?
Yeah, just a bit for you there. The meteor showers, we do bounce a lot of VHF, UHF signals off them. So when we get big ones, we're getting, 2 metre band is probably about 300 or 400 Ks to work. When you get one of these showers, you can work into Queensland with it. That sort of thing.
Yes, and
propagation.
Jim would have talked about that last time as well, yeah. And he's actually given a talk to the ASV about that as well. Yeah. Yes, ma'am.
Just ask you, on a few occasions I've seen green either shoot out of the sky and basically land. But I've never tried like the sort of green, a bright green. What are they?
They're meteors. They're falling to a layperson, a non-astronomer. They're falling stars, or that's what you would call them.
Yeah.
The green has something to do with the chemical composition of that particular grain that's burnt up in the atmosphere.
So basically what you're saying would still be the same size as a...
Oh yeah, yep.
And yet it looks bigger when it's...
Oh, look, it does, and I can absolutely guarantee you none of the ones you saw hit the ground.
I'm not sure about that.
Oh, I am.
This one actually was in a paddock near where I lived, and it actually sort of shot past.
Yep.
And it appeared to land in the ground.
How bright was it?
It was very bright.
Okay, was it bright enough to light up the whole area and cast shadows?
Not, well, I can't say that for sure, but it did light up a reasonable area.
And I've seen ones, well, it would be if you've not seen one before, but I've seen ones that have made it daylight. You could see everything just like day. But there was a slight difference about how everything looked because of the colour, but it was daylight. Shadows were cast all around, and that just burnt up in the atmosphere above our heads. Now, occasionally there, more questions, I'll get to you in a moment. Occasionally, some are coming directly at you, and then all that happens is they just appear to get a point source that gets brighter and brighter and brighter, and then just fades without any trailing at all. And I was fortunate enough, because it is very rare, fortunate enough to have witnessed that with a couple of hundred people sitting around me, and I happened to be pointing in the right part of the sky when that occurred, and everyone just, got such an amazing thrill out of it, and I had to yell out, "Duck!" But it didn't get that far. Yes, ma'am.
Well, what would happen if a small object of small rock size came down? Small rock.
It would burn up in the atmosphere.
So,
yep. It has to be quite a size to survive the passage through the atmosphere. And I want to dispel one other thing here. All through my schooling years, I was told, and I bet you were too, that it was, what made it burn was friction. Not so, grasshopper. What happens is it works exactly the same way as when you pump up your bicycle tyre. What happens? You pump it up, what happens to the pump? Why? Exactly. This object is coming in through the air so fast that the air cannot get out of its way. It gets piled up in front of it, getting squeezed more and more together till it becomes so hot that it burns up the meteor. And there is a difference in the names as well. When it's moving in space, it's called a meteoroid. When it enters the atmosphere, and we can see it with those magnificent trails, it's a meteor, and if it actually hits the ground, it's a meteorite. Now, sometimes people go out looking for these things, and there's a program on TV, and they use metallic detectors, and they run into nails and what we like to call meteor wrongs instead of meteor rights. Yes, sir?
What sort of size do you imagine the one that came down over Russia recently?
It was about 10 to 15 metres in diameter.
Like I said, the last revision I heard was they were saying it might be as many as 10 times or 100 times that there was something came out just a few days ago and said that they had re-evaluated it and they thought it might be a lot bigger than they originally thought.
If it was much, much bigger, it would have caused much more trouble. So I haven't seen that report. I'm not saying it's not true. But the one, who saw the movie Wolf Creek? The Australian movie, and it's centred around the Wolf Creek crater in Western Australia. And that's a kilometre or so in diameter, and that was done by something that was about 50 metres across.
Meteor crater in Arizona, how big do you think that would have been?
That was about the same size. Yeah.
That size at time of impact, that's how big the meteor.
Yeah. Now, also there are a number of other factors that come into play here, and that is the composition, is if it's iron, or whether it's rock, stony, or whether it's a loose-based aggregation of material. All of those factors come into it as well. The one in Siberia in 1908, June the 30th, that exploded before it actually hit the ground. And that was, I think, about 80 to 100 metres in diameter, they were saying, and it levelled forests for, I think it was 200 square kilometres. All the trees were knocked down. But because it was in Siberia and extremely sparsely populated at that time, no one person lost, no human life was lost. There were a couple of reindeer herds that were very close to the epicentre, and they were just incinerated. But the only injury that was caused was an old man that was knocked out of bed by the sonic boom and he broke an arm. Yes, ma'am?
The Tunguska one did not leave a crater.
No.
And, which is rather unusual, and it was not round, it was cylindrically shaped. And there were several other very strange characteristics about it.
There was no crater because it didn't impact. It exploded about 20 kilometres above the Earth. And that force, there was a study done where the force goes out in a butterfly pattern, and that was also seen in the way that the trees had been knocked over. So there we go. These are meteor showers, which are very small particles compared to these other much larger objects, which are not part of meteor showers, and they have to be very small, tiny particles in meteor showers because they basically are boiled off comets by their proximity to the sun. As comets come in close to the inner solar system, their tail basically seeds the orbit behind them and in front of them, and it's this material which, if it was very large, would not boil off. I mean, gravity is very important in this factor, so they have to be tiny in order for them to come off the comet. Plus, there's been experiments done where we've gone to the upper atmosphere and collected this material. with balloon flights and special airplane flights, and it is tiny. All right, let's move on. Here's another one, this time the Orionid meteor shower, and again, here's the belt stars of Orion, the saucepan, there it is there, and all of these appear to come out of a single spot. Probably the best meteor shower of the year for the southern hemisphere is the Eta Aquarid meteor shower. You're in luck, ladies and gentlemen. It occurs on the morning of the 6th of May. Get up early and start looking towards the east, about halfway up towards the sky, and they are at their best in the couple of hours before dawn breaks. So if you do get up that early, or if you want to set your alarm and get up that early, then if it's clear, you may be fortunate enough to see some of these meteors. And from a dark sky site away from the city, you can see as many as about 30 to 40 of these per hour, if the moon is out of the sky. Quite a few less, maybe a third as many if you're observing from the city. But you can't just go out there and spend 2 minutes and say, oh, there's none. You have to sit out there for at least an hour and observe them. The best way to do it, and again, you require no special equipment whatsoever, nothing scientific at all, except for perhaps a thermos flask full of tea or coffee to warm yourself up, and perhaps a little side flask of cognac or whatever it is that you can use to warm yourself up. But essentially it's the laziest sort of astronomy that you can do, because you just get into a sleeping bag and you lie in a banana lounge and you just watch. That's all you do. Yes, sir?
Would it be fair to say that the people sitting in the International Space Station would be a little bit nervous on that at that time?
Oh, look, it depends on their position, and these sorts of rates are not enough really to be challenging it. If it was a meteor storm, sure. Back in 2001, when the Leonid meteor shower was at its peak, I know that a number of satellites were switched off and they were put into a position that showed that had minimal minimal exposure and a tiny silhouette towards the position of the meteor shower. But no, I don't think they'd be very nervous. I think they'd be more nervous about some of that dodgy Russian food that goes up there, actually. Yes, so morning of the 6th, if you're not doing anything special, or if you're an early riser, get out and have a look at the Eta Aquarids. And again, I will tweet a message about it. The other thing I tweet about is whenever there's an aurora, or likely to be an aurora. And here is an aurora. Some of you may recognise where this image was taken from. Anybody? Ricketts Point is right. So you don't have to go all the way to southern Tasmania, and certainly not Antarctica, in order to see an aurora, but it has to be a pretty good one. This was taken by Russell Cockman from Ricketts Point, which is just down the road from my house, about 3 or 4 minutes away, and I often drive down there. You go to the far left of Ricketts Point, where there's no car park lighting, and you just try and look south. It's not as good as going down the peninsula, but if you've only got a few minutes to get down there while it's active, that's where you would go. And these are the lights of Frankston. This is Mornington, and further down Sorrento and whatever. Now, another gloriously aesthetically pleasing image, and that is Comet, or a comet that was visible a couple of years ago over Christmas. By the way, this is not a full stop or a dot. It's just an imperfection in the board, so don't include a stop there. I thought I may have put a dot on there, so it doesn't exist. Comet Lovejoy was a comet that got very, very close to the Sun. We didn't even expect it to get through its journey around the Sun. We expected it to be destroyed by the Sun, but it did manage to get around, and right over the Christmas period, and it was called the Christmas Comet of 2011. It was a beautiful sight early in the morning in the days leading up to Christmas and just around Christmas. This is taken at Cape Schanck, and again there's the emu in the background, and it's just a fabulous image. Nothing special, just a camera on a tripod and just a bit of good framing of the foreground. And I reckon this is about as good as any painting by Claude Lorraine or any of those guys of the Barbizon School or whatever. It is just a superbly constructed image of the starry sky and the foreground. And again, taken by Alex Cherney of the dish. Beautiful composition of the trees, the Milky Way, the tail of the scorpion way up high, the head of the scorpion, there's the heart of it, Sagittarius over here, and all of the Milky Way being visible at the same time. And this is the setting moon as well. Just beautiful, stunning stuff that you can just do with your own camera.
Is the dish lit up so much for the photograph?
No, there is a little bit of ambient lighting within the grounds. Now, the final couple of images I want to show you, or penultimate images, have been taken by telescopes. But I'm showing them because I want to make a special point. Any astronomer that's worth his salt can tell you a lot about an image when they look at it. I know what this object is. This is the Hamburger Galaxy, and it's called that because there's a piece of meat around two buns. And it is a strong radio source, in fact, as well. It's such a strong radio source that it's called Centaurus A. And much of the early radio astronomy that went on was observing this object in the southern hemisphere. It's a galaxy that's just like, I suppose, the Milky Way. It probably contains about 300 billion suns, just like our Milky Way galaxy does. And this is a dust lane in the middle. And I can tell you that this was taken by a certain type of telescope, because the telescope betrays its presence, or the optical system betrays its presence in the image if you know what you're looking at. But I'll move forward and show you another image. In the late 1990s, Comet Hale-Bopp, some of you may have heard about it. Did any of you see it? Gentlemen up the back. Not anywhere near as impressive as Comet Hyakutake or Comet McNaught, because in the southern hemisphere it didn't get to a position of great advantage for us, but it was quite an impressive object in the northern hemisphere. Did you see it here or overseas?
Overseas, New York.
Right, that'd be impressive.
Yeah, I saw it in New York City with the city lights. You could still see it.
Yep, well that would have been pretty impressive then. This image was taken by this dude called Chuck Schramek, and he was a doctor, in fact. And when an object such as this comes around, there's lots of people that are drawn to astronomy and astrophotography because they want to take a photograph of an object such as this for posterity or for whatever. And this guy bought himself a telescope, and he thought, I'm going to go and take a photograph of Comet Hale-Bopp, and he did. There's the comet and a bit of a tail. This was before it was at its best. And when he looked at the image that he took, he thought, wait a minute, what is going on here? Because I've got the comet, but what about this Saturn-like object right next to it? Now he knew enough to know that it wasn't Saturn. And he thought, this is really shifty. This might be a conspiracy the astronomers don't want us to know about. It could be a spaceship. So what does somebody like that do? They get on a coast-to-coast radio show that deals in the paranormal, and now, do you know the guy's radio show? Now what's his name? I've forgotten. But anyway, he has a huge listening audience, and it's all very do-do-do-do-do-do-do, that sort of stuff, you know. And he got on there, and so the charges were made. NASA and the whole astronomical world is keeping it from us. There's a spaceship trailing this comet, and nobody has told us anything about it. Why are they keeping it a secret? The public has a right to know. Strangely, when I saw this image, I talked about it in one of my talks. I was president of the Astronomical Society of Victoria at the time, and I talked about this, and I said, there's some banana, I used very unflattering words, suggesting that this is some sort of spaceship trailing Comet Hale-Bopp, and we're all keeping it secret, and we don't want the world to know. And sorry? No, the camera doesn't lie. Now, when I looked at this, immediately I knew what was going on.
Product of the telescope.
It is. Now, here's what happens. I'll draw it. When you look inside a telescope from the front of the telescope, especially if it's a reflector, there's a mirror down here at the bottom of the telescope. that collects the light that comes down into this mirror, and then it's reflected back to another mirror which is set diagonally and points the light out to here where you look at it, right? Where our eyes are looking. Now this other mirror up here, and I'll draw a view looking straight down now. Usually most telescopes hold that mirror in the middle here with 4 vanes like that. We call them spider vanes, and that's what it looks like. The other mirror, the main mirror, is down at the bottom. These spider vanes then tell me when I look at this image that that's the sort of telescope that was used to create that image, and they betray their presence in those 4 spikes that you see on the stars. Sometimes you get a telescope that only has 2. Here's where, unfortunately, a little bit of knowledge is a dangerous thing. That program, the radio show, and this image, some of you may have heard of this. There was a gentleman who led a quasi-religious group, the Heaven's Gate cult, and their little doctrine was that, or when this guy, who by the way, who was the leader of this sect, had already been proven by doctors to be a star or 2 short of a constellation previously, was leading this group. And he said, this proves what I've been telling you. This is the spaceship that we are going to rendezvous with after we die. 53 of them committed suicide to rendezvous with this object.
I think that was disappointing.
They would have been very disappointed, but what a terrible waste of life that began by somebody that had no idea what they were doing. Because no astronomer that knew what he was doing would have said, oh, this is a spaceship following blah, blah, blah. What is this object? Anyone would have, that had done any photography, astrophotography before, or knew much about astronomy, would have looked at it and gone, well, yeah, it's an artefact of the optical train. I don't want to finish on such a sad note, ladies and gentlemen, so I'll finish on this one, which is a fantastic image. Can somebody tell me what's going on? Time lapse for sure. Sorry? These trails here are all stars that have trailed around the North Celestial Pole, which is the point directly above your head if you're standing at the North Pole, as seen in the sky. And so during the course of an evening, the stars all appear to go around it. You leave the shutter open for 15 minutes, 20 minutes, an hour, whatever you like, 5 minutes, and you get this trailing as the stars move along. And by measuring the distance in degrees of that trail, you can work out how long the exposure is. 360 degrees, 24 hours, right? But these other objects here are fireflies. And so you get this magnificent image. I think it was shot close to Halloween, if I'm not mistaken. In the northern hemisphere, we don't get as many fireflies as that in the southern hemisphere. And so there's a range of stuff that you can do with just a simple digital device. Adventures with your digital camera, ladies and gentlemen, and I thank you for your attention. Should we take some questions? Jack, do we have some time?
Yeah, time for questions, yes.
A little bit of time for some questions, if anyone's got any. Yes, sir.
Did somebody walk in front of the camera at one point? Was it a break in all the trails?
This...
No, each of the trails.
There, yep. Not necessarily someone walked, but perhaps something could have happened to the lens, or something could have fallen over the front of it, or whatever. And this is planes coming into land. Right, those straight lines. Any other questions? Yes.
Could you write the important dates on the board?
There are many of them. What's your name again? Josh, there are many of them. Do you go online and do you get onto Twitter? If you get onto Twitter or the Facebook page of the Astronomical Society of Victoria or the Facebook page of Mount Burnett Observatory, then you get all this news just before it happens, or with enough time so that you can prepare with it. So that's what you need to do, get onto those. Any other questions?
There's a star with a lot of mass, I think it's out Comet, is that right? It has a lot of mass and it's actually pulling itself apart. It will probably nova one day. How bright? A massive object like that.
It will never nova. It will supernova.
It will supernova. And I take it would be very, very bright once it's done.
It will. It's a good supernova candidate. It's between the Southern Cross and the False Cross. In fact, it's in a little cloud of gas in the brightest part of the Milky Way to the right of the Southern Cross. It's between the Southern Cross and the False Cross.
I've seen it in a telescope, and it's a very unusual shaped object. It almost appears as a dumbbell sometimes.
That's just the gas. But the object itself, the star, is spherical, but it's let out, it's pushed out material from its magnetic poles that have formed the shape almost of an hourglass, because it's just pushed it both ways, with it being in the centre. And it's that dust which is sometimes called the homunculus nebula, which is what you would have seen.
So it's true to say that the object's got so much mass it can't even hold itself together.
Well, it is holding itself together, and in fact the gravity will win in the end. The radiation outwards is not going to be able to stop it, and when it runs out of fuel and there's no more radiation pressure from the nucleus, the outside of it will compress in the blink of an eye, and then it will rebound in an explosion of supernova. And yeah, you'll be able to see it during the day for a number of weeks. Yep. Sorry? Look, any time in the next few thousand years. Could be tomorrow, could be 5,000 or 6,000 years' time.
Probably know about it when it happens.
Oh yeah, oh yeah. In fact, we're due for a supernova in our Rhone galaxy, because there hasn't been one since the time of Kepler, early in the 1600s. I think it was 1604. Usually, on average, we have a supernova in a galaxy the size of the Milky Way about every century. And it's been quite a few centuries since then.
Sorry,
Yes, ma'am.
I just want to go back to the meteors. Is there a difference between the meteors in the southern hemisphere to the northern hemisphere? And if so, what's the difference, and why can't Australian meteors be taken out of Australia?
Well, as soon as you try and take meteors from Australia out of Australian, the tyre slashes come up, the bars go down, the bells ring, and the federal police grab you. It's just the government doesn't want that to occur.
Did you tell the difference between the samples?
No. They're exactly the same, whether they're northern hemisphere or southern hemisphere.
You can take them from the northern hemisphere, right?
It depends on which country they were discovered in, because some countries won't allow you to do that.
There was a program on TV on one of the cable, and there were meteor hunters.
Yes, the meteorite men.
Yeah.
Those guys are crazy.
They were able to take them wherever they wanted to and sell them, and yet they couldn't take them from Australia.
No, not from Australia. The laws are very strict.
Cultural Heritage Act, and I spoke to one gentleman over that particular matter.
Oh, right.
He was federal police.
Oh, okay. Right. Nudge, nudge, wink, wink. No more need be said. Final question. Josh, do you have another question to ask? No? Well, this gentleman can have the last bite at the cherry.
I just wonder if you could clarify something.
If I can, I will. If not, I'll just make something up.
One of your an earlier slide showed the laminar perspective, which was the photograph of the sun, which was taken every week for 1 full year.
The analemma, yep.
Approximated a figure 8.
Yes.
I believe you said at the time this was the sun's movement during the course of the year. Does that mean the sun has actually got a wobble, or what we're talking about, the sun is stationary and the earth is going around it and the earth too has a wobble?
Look, it is part of it. It's, yes, the same reason that we have seasons, but also there's something else which is involved, and that is the sun, or the orbit of the earth around the sun, because our orbit is a little bit oval, right? And so if the sun is about here, then in this period, when we're in this part of the orbit, we're moving faster than in this part of the orbit around here. And it's part of the equation of time, and we refer to it as the fast sun or a slow sun at different times of the year. So sometimes the sun is past the north-south meridian at midday, and other times it's a little bit behind.
But the bottom line is the sun is actually stationary in space.
Well, it does a very tiny wobble, but not enough to influence that image. You need to measure it with very, very fine instruments.
The Earth itself has a mutation. The wobbles are happens.
Yes, because there's nothing in space that stays perfectly still. If there is something seriously wrong, and you better go and take all that money you have stashed in the bank and spend it before it's too late.
Another chance to start a new religion.
Thank you for your attention, everybody.
Thank you for coming out and giving us that wonderful talk tonight. And on behalf of the club, I'd like to present you with a little token of appreciation.
Thank you.
Which you probably have all your astronomy stuff in and that sort of thing. So you've probably got no room knowing all your awards and stuff. Years to put something like that up. But thank you very much for coming along tonight. Wonderful.
Thank you very much, John.